today I want us to do the theorems for Euclidean geometry. So I just hope it's visible. Okay, it's Euclidean geometry. Okay, so we'll focus on the theorems. So the first one that we're going to look at is a cyclic quad. So a cyclic quadrilateral, it has 4 vertices on the circumference. Oh yeah. 4 vertices on the circumference. 4. So this is a cyclic quad, and then sometimes they can give you something like this. To check if you know a cyclic quad. So this is non-cyclic. It's not a cyclic quad because it doesn't touch the circumference 4 times. So it just touches it 1, 2, 3. So a cyclic quad touches the circumference 4 times, which is here, here, and here. Okay, so we're going to check how to prove a cyclic quad. So, okay, let's say we have something like this. It's a line here and then goes like this. So you need to remember that this here is equal to this. And then the reason is because the exterior angle of a cyclic quad is equals to the interior opposite angle, which is this one. So to make sure that it's a cyclic quad, I said you must check your circumference if it touches it 4 times. So it's 1, 2, 3, 4. So it's a cyclic quad. And how do you prove it? You check, this is the exterior angle of a cyclic quad that's equals to the interior opposite angle. Exterior angle of a cyclic quad is equal to the interior opposite angle. So the second scenario is that you might have your cyclic quad like this, and then it touches 1, 2, 3, 4. So this can be your A, your B, your C, and your D. So another thing is that the opposite angles of a cyclic quad are supplementary, meaning that when you add this angle and this angle, they must sum up to 180 degrees. And when you add this one and this one, they must also sum up to 180 degrees. So it means that in cyclic A, B, C, D, when you add angle A plus the angle C, they must give you 180 degrees. The reason is that opposite angles of a cyclic quad are supplementary. Right? Similar to angle B and D. So you can say angle B plus angle D is the same as 180 degrees. Same reason that the opposite angles of a cyclic quad are supplementary. So we come to the third one. I hope it's still visible. So let's say you have a cyclic quad like this. Okay. Okay, something like this, ne? So this is A, B, C, and D. So A, B, C, and D is a cyclic quad. Why? Because it touches the circumference 4 times 1, 2, 3, and 4. So now you need to check in order for you to prove. You need to know that if this is X and this is also X, because they are angles from the same segment. These are angles from the same segment, or they are the angles from the same chord, which is BC. So you can prove using this, saying that this is a cyclic quad because angle, okay, B, angle AC is equals to B angle DC. B angle DC. Your reason, angles from the same segment or angles from the same chord BC, right? So okay, we'll stop here and then we'll check the other theorems. Okay, so we're going to continue with the other theorems. So now we'll look at the tangent. So what is a tangent? A tangent, it's a line that touches the circle or the circumference. Is the circumference once, right? So let me give you an example of a tangent. So let's say you have something like a circle. This is your center O. So a tangent will pass once. It's either it can come this side, or it can go from here to there, or it can go from here to there, as long as it touches the circumference once. But then when you have something like this, this is your circle, this is your center O, and you have a line passing like this. This is not a tangent. Why? Because it touches the circle twice, touches the circle here and also here. So it is not a tangent. A tangent doesn't pass like this because this touches the circle twice, 1 and 2. So how to prove a tangent? How to prove a tangent, right? So the first thing, we have a tan chord theorem. So you can have your circle like this. You have a line that touches the circle once and something like this. So a tan chord theorem, this is a tan chord theorem. How do you see? The angle between the tangent and the chord is equal to the angle at the circumference. So that's why we said it's a tan chord theorem, right? Okay, so if this is an X, this is going to be an X, meaning that if you have A, B, and C, so you know that your angle at A is equals to, okay, let's say you have D here, C, angle B, D. Why? It's a tan chord theorem, right? And then the second theorem of a tangent is that you have a radii and a tangent. So a tangent, we stated that it touches the circle once. So here it touched the circle once, so hence it's a tangent. So we need to know that this is a 90 degree and this is our center O. And this can be A and then B. So we need to know that this angle here is equal to 90 degrees, angle A, O angle AB must be equal to 90 degrees. Why? Because the tangent is perpendicular to the radius, hence it's 90 degrees. Therefore, we say that it's tangent perpendicular to the radii. And then the last theorem for a tangent. Let's say we have two tangents, this one from here and another one coming here. So this is point T and this is R and this is an S, right? So these are two tangents because this touches the circle once and this also touches the circle once. So we say that we have a radii, our center, and a radii here. So this is our O. So this is 90 degrees and 90 degrees because the tangent is perpendicular to the radius. But what we need to know that the tangents from the same point, they are equal, right? So ST is equals to TR. This side is equal to this side. Why? Because they are tangents. We say ST must be equal to TR. The reason is that tangents from the same point.